Okay, we are going to combine absolute values and inequalities together and solve absolute value inequalities. So the absolute value of x is less than a means it's the distance from x to 0 is less than a units. When we do less than, when we have it set up like that, where you have your absolute value, you have the less than, and then you have equals something on the other side. We are going to do this in, remember the and statement? So add a D at the end of less than. Because this is going to help us remember how we're going to shade. So remember with and statements and inequalities, we're going to shade between. And then if we, so see how it's less than? So we're going to shade between. When it's greater than, the distance from x to 0 is greater than, we're not going to write greater like that. We're going to write great or than. So greater than is going to be shading opposite directions. So great or than, less than is going to help us. Okay, so you're going to have to look at what the symbol is. So let's start with example 1. We would need to solve it out, get the inequality back by itself, or the absolute value by itself, actually. And then we can decide how it's going to be shaded, and we'll go from there. So we're going to add 2 to both sides. So we have 3, absolute value of 2x minus 1. Less than 15. Then we're going to divide by 3. So now we have the absolute value of 2x minus 1 equals, no, not equals, sorry, less than 5. Okay, so at this point, we can decide how it's going to be shaded. And then we find the 2 numbers that we're going to shade, either opposite directions or in between. So this is a less than. So we're going to write that less than and underline and. This is just to help us remember how we're going to shade. So we're going to shade between. So between what? Well, we've got to find that. Remember how we solved absolute value? We wrote 2 equations. So our 2 equations are going to be 2x minus 1 equals 5. And 2x minus 1 equals negative 5. We solve both of these out. So plus 1. So we have 2x equals 6. Divide by 2. X equals 3. Before we put on the number line, we've got to find out what the other number is so we can fit both of them. So I'm going to do plus 1 on both sides. Divide by 2. Okay, so our number line is going to have the two numbers, -2 and 3. Which one's smaller? -2. So that's the one that we'll put on the number line first. Then you have a bunch of numbers, and then you get to 3. So I'm going to put 3 on the other side. And it says less than, so that means we're going to shade between. But we need circles on it too. So see how this is less than? So it's going to be an open. So open circle on both. And what this means is every number between here will work on this inequality and on the absolute value equation. So we can put this into y equals and see that the numbers in between -2 and 3 will work for the absolute value. Okay. So we could check those. Okay, let's go to the second one. Before we set two equations, we've got to get the absolute value alone. So draw your line down your inequality. We have -2, and then the absolute value times something is less than or equal to -12. What do we need to do to get the absolute value alone? What? Divide, because this is the operation to multiply. So then the opposite would be to divide by -2. So then, yeah, we got to switch that sign. So it's going to be absolute value of 2x plus 4 is now greater than or equal to 6. So let's talk about what this means. What kind of circles will we have? Open or closed? Closed, because that's or equal to, so it's closed. And then what symbol is that? Is less than or great or? Okay, so let's write great or. Underline the or. That's telling us how we're going to shade. Great or goes the opposite directions. Okay, so we need to write two equations. So 2x plus 4 equals 6. And then 2x, so it's going to be or, 2x plus 4 equals -6. So even though we have the inequality symbol, when we solve the absolute values, we say they're equal, so we can figure out those two numbers that we put our circles on. The first equation, x equals 1. Okay, second equation, let's do that. Then we have -5. Let's draw our number line. What goes first on the number line? What goes on the left side? -5 because it's smaller. And then 1, so -4, -3, -2, -1, 0, 1. And then up here we said that they were both closed. So both closed. And it's a great or, so we're going to go to the greater side, which means Opposite directions. Shade opposite directions. Okay, let's go to example 3. Absolute value of 2x plus 1. Don't start graphing it or solving it yet. Y'all wait. Do y'all remember what happens when you have absolute value and then you have a negative answer on the other side?
We have no solution.
We have no solution, but with inequalities, we could have a solution. So let's think. What's going to always happen with absolute value of 2x plus 1? What is it going to be? What do absolute values do? Make it positive. So any positive number. Is any positive number greater than or equal to negative 9? Where does it start working? At 0, at 1, at 2. Can I find all of those numbers? What's it going to be? This is always going to be positive. So this is always going to be true. Because every absolute value that I find is going to be a positive number. So even if I plug in x at negative 10, it'll still come out to be positive because that's what absolute values do. So this is always true. So when it's always true, our answer is not no solution. It's all real numbers. It's every number. X can be all real numbers. All real numbers. Any number you plug in for x will work. So remember the R with the extra line on it? All real numbers. From negative infinity to positive infinity. Any number you plug in for x will work. So we don't have to do a number line. But if we were to do a number line, you know what it would be? You would shade the whole thing. Go in both directions. And let's just put 0 on there just for fun. Just so we have a number. Okay, example 4, our last one. So before we start doing anything, see how this says negative 8? We've got to see if this is always true or never true. Okay, the absolute value, x minus 5, this is always going to be positive, right? So this is a positive number. Is a positive number going to be less than negative 8 ever? So this is never true. The other one was always true. This one's never true. Because it can't be less, a positive number is never less than negative 8. So then this one is a no solution. So if we had a number line, nothing would be shaded. It would be empty. We would let it be.